guys, welcome to today's class where we'll be looking at random examples on polynomials. We have rounded off the major part of polynomials. So today we'll just be looking at how different ways and areas we can be tested under polynomials generally. So combining your knowledge of addition, subtraction, multiplication, division of polynomials, then factor theorem and remainder theorem, combining all that knowledge into different various miscellaneous questions. So that's what we'll be looking at now. So we have this example here, example 1, where we have a polynomial p of x is defined in terms of a constant a by p of x equals to x raised to power 4 plus 2x cubed plus 9x plus a. Full stop. When p of x is divided by x squared minus x plus 2, the quotient is x squared plus bx plus 1, and the remainder is cx plus 5, where b and c are constants. Full stop. Find the values of a, b, and c. Now, if you look at this question critically, you realize that we have a particular polynomial, even with some particular unknown values, okay, a particular unknown value, and then we are given a divisor, which is, okay, then we are given the quotient, which has an unknown value b, and then we're also given the remainder, which has an unknown value c. So, first of all, we have f of x, p of x rather, given as x raised to power 4 plus 2x cubed plus 9x plus a. And then they give us the divisor. The divisor is what? Is x squared minus x plus 2. And then they give us the quotient. The quotient here is x squared. And then the remainder, cx plus 5. And then we are asked to find a, b, and c. Now, first of all, we have to recall from our knowledge of polynomials from the beginning when we did the remainder theorem. We remember that we said that when we did division of polynomials, we said that the quotient of any polynomial times the divisor plus the remainder should give you your function, that is your p of x in this case, the polynomial. So if that is the case, it means that when we multiply our quotient here, because this is q, and our divisor d, and then add it to our remainder r, it should give us our polynomial p of x. So by that, I can say x raised to power 4 plus 2x cubed plus 9x plus a is equals to, my quotient in this case is x squared plus bx plus 1. My divisor is x squared minus x plus 2. And my remainder is cx plus 5. So now that I have the three of them, I can now expand this. So I have x raised to power 4 plus 2x cubed plus 9x plus a. I open the bracket here, I'll have x raised to power 4 times this, I'll have minus x cubed from my knowledge of multiplication of polynomials plus 2x squared plus bx cubed minus bx squared plus 2bx plus x squared plus, minus x. So we have 1 times minus x, so that gives us minus x. Then plus 2. Then coming to this side, we have plus cx plus 5. Okay, so that is what we have there. Now we are comparing. So we have x raised to power 4 plus 2x cubed plus 9x plus a. This is x raised to power 4. We look at the x raised to power theories. We have this and this. We bring them together and factorize. Okay, let's bring them together first. We go to the squares. We have 2x squared. We have minus bx squared. And we go to the x's. We have plus 2bx. Okay, we have plus x squared here also. Then we move on. Then we have plus 2bx. Then we have minus x plus cx plus 2 plus 5. So now that we have this, we can now simplify. We have x raised to power 4 plus 2x cubed. From here, we know x cubed is common, so I can say plus b minus 1 into x cubed. This will be what? Plus 2 plus 1 here gives me 3 minus b into x squared plus b plus c minus 1 into x plus 7. So we have this as our, after factorization, The next thing we do here is to compare coefficients. So we look at this one. We say by comparing coefficients, I can say that x4, okay, they are the same thing. Since this is x cubed, this is also x cubed, I'll compare the coefficient, and this 2 will be equals to b minus 1. If 2 is equals to b minus 1, then I can say b equals to 2 plus 1, and then my b is 3. I can also take out another one. I can also compare 9x and, oh good, I don't even have x squared, so I can just put it as 0x squared. So I don't have anything in terms of x squared. I'll just say 0 equals to 3 minus b, which also shows me that b is equals to 3, which I've also gotten here before. Okay? By comparing coefficients still, I can also see that for my 9x, I can compare 9 to b plus c minus 1. That is 9 equals to b plus c minus 1. Where my b is 3, that is, I can say 9 equals to 3 plus c minus 1. Where we have c equals to 9 minus 2. Where my c will now become 7. My c is 7, and comparing the last one, in the last comparison, where I know my a is equals to, the constant, and then is equals to 7. So I've gotten all my values of a, b, c, and d, and then I can round it off, and then say, therefore, my a equals to 7, b equals to 3, and c equals to 7. Then if we are asked to actually find the polynomial, okay, the polynomial itself is not asked, we are not asked to find the polynomial itself. All we have to do is find the values of a, b, and c, which we have gotten here. So in the next class, we'll be looking at another example on how we can, another random example on how we can actually combine, how it can be tested by combining all the principles we have actually worked on today in other classes and in this class, and how we can combine those principles to be tested in a particular question. So, see you next class. Have a nice day.